Okay, so today lecture is basically all about the metamorphic reaction. Okay, we'll go through a different type of metamorphic reaction. So this is not the comprehensive course. ठीक है जो सारे different type of mechanism I'll explain just whatever is needed for the एग्जामिनेशन पर्पज. ठीक है, जो कि आपको हेल्प करेगा ताकि यू विल गेट सम एडिशनल मार्क. ठीक है. Why you using normally metamorphic reaction? Just tell me. Can anyone? What is the implication or like application of the metamorphic reaction? Why we normally study the metamorphic reaction? कोई बताएगा? Why? Also, it is benefit for the GSI mains. You can write some of the things, right? You should write some content regarding the metamorphic reaction, or like the implication is also in the metamorphic zone. Also, you can write the different type of metamorphic reaction in metamorphic zone question. ठीक है, अगर कोई physics से question आता है, right? So you can write some of the content. Ruby, are you fine with Hindi or like it is completely English? Okay, that's great. So what is the implication of the metamorphic reaction? हम क्यों पढ़ रहे थे? Normally हम क्यों पढ़ रहे हैं this type of content? Anyone? Anyone? Yeah, you can say, but that is not the most important and utmost priority that you are saying. You can understand the mineral assemblage. The main objective is to understand whether the particular mineral is stable under the particular pressure temperature condition or not. ठीक है? Pitting condition. Right? If you talk about chloride zone, ठीक है? So in that chloride zone is the biotite will stable? Biotite stable हो सकता है क्या बताओ? नहीं, right? So from that chloride zone you infer that only chloride mineral will stable. Maybe some other mineral आ सकता है, but only chloride mineral is stable in the chloride zone. Am I right or wrong? So be it like a metamorphic zone or be it the metamorphic phases, you can understand the different type of mineral assemblage and the stability of the mineral in the pitting condition. Are you clear or no? Like, are you getting my point? What I am saying? Okay, that's great. So suppose I am saying is, let's talk about air to SiO5 system. Okay, let me add some of the pages. And before coming to metamorphic reaction part, let me ask some of the question. Okay. So what is about this field? Can anyone say? What is this field? Anyone? Ruby, you tell me, what is this? This field, I am talking about this field. Yes, the whole system is exactly right. It's kinetic only. Okay, what about this field? And W side, what about this field? This is sillimanite. Am I right or wrong? Sillimanite is stable at the high temperature condition. Kyanite is stable at the high pressure condition. Okay? So whole the system is aluminum silicate. This is aluminum silicate, है ना? This is very important. Aluminum silicate is very important not only for the like understanding the metamorphic process and the metamorphic reaction, but also implication on the क्रिस्टलोग्राफी बहुत सारे क्वेश्चन आता है, लाइक काइनाइट कौन से सिस्टम पे क्रिस्टलाइज करता है ना, व्हाट इज द हार्डनेस ऑफ द काइनाइट, राइट? प्लीज गो थ्रू दिस, राइट? एंडालुसाइट, सिलिमेनाइट, एंडालुसाइट, सिलिमेनाइट. Read the physical and optical properties. Physical and optical properties of the aluminum silicate mineral. ठीक है? Now tell me just how do you find the slope of reaction or slope of line? Let me ask, like slope of line. कैसे आपको पता चलेगा? Exactly, very good. By using the Clausius-Clapeyron equation. What is the Clausius-Clapeyron equation? I am not going into detail because like this is not the comprehensive course. I already said it is completely revision course, so that you can acquainted and get like much more marks, additional mark. ठीक है? Clausius-Clapeyron equation बताओ क्या होता है? dp by dt equal to del s by del v, right? What is the p? It is pressure, t is temperature, delta is change in entropy, and delta v is change in volume. Clear? So normally let's forget about Clausius-Clapeyron equation. Normally कैसे slope हमको find out करना पड़ता है? Normally बताओ, normally Ruby, Tridip, it's completely tan theta, right? Slope is tan theta, right? Suppose this is the point, coordinate x1 y1, this is the point coordinate x2 y2. What is the slope? This is the slope, theta. Am I right or wrong? What is this length? y2 minus y1, right? But what about this length? It is x2 minus x1. So tan theta will be delta y by delta x. Am I right or wrong? समझ में आया या फिर any doubt you can ask? Clear? Yes. Okay. You can respond, right? Otherwise I feel bored. Delta y by delta x. So delta y is y2 minus y1. Delta x is x2 minus x1. Clear? हुआ कि नहीं बताओ? So m will be tan theta. M for slope. है ना? So slope से पता चलता है हमको. You can find the variability of the line, whether the slope is gentle slope, whether slope is steep slope. Clear or no? इतना समझ में आया या नहीं बताओ? Okay, that's great. Let me ask some of your question. Okay. Again, pressure, temperature, condition, suppose. ठीक है? This slope is gentle or steep? Just tell me. Slope. Gentle slope, right? Now what about this slope? This is steep slope. Clear? इतना समझ में आया? Okay, that's great. Let's talk about the phase rule. Because no, you should understand the basic concept for the metamorphic reaction, how the reaction is happening, why it is concave upward. Not this, for particular reaction, for particular reaction. ऐसे तो मैं मतलब ड्रॉ कर दिया, but when you study the metamorphic reaction, you should understand from the metamorphic reaction why the slope is concave upward, whether any type of volatile is present or volatile is released or volatile is consumed. You should understand. ठीक है? Phase rule. What is the phase rule? Just tell me. बताओ. P plus F will be C plus 2. What do we know by P? Number of phase. F, degree of freedom. Please go to the my like phase rule video in the YouTube, right? You will understand properly the concept of phase rule. C will be number of component. कंपोनेंट क्या है, फेज क्या है, वहां पे बताया हूं डिटेल पे. ठीक है. व्हाट अबाउट दिस टू? दिस इज इंटेंसिव वेरिएबल, राइट? व्हाट डू मीन बाय इंटेंसिव वेरिएबल? पिछले क्लास बताया था, राइट? प्रेशर एंड टेम्परेचर, राइट? That variable doesn't depend upon the mass of the quantity. Yes or no? Okay. Let's talk about now. Same system, huh? Al2SiO5 system. This is kyanite, this is andalusite, this is sillimanite field. ठीक है? Okay. Let me talk about what do you mean by invariant point. I am talking about only metamorphic system है. ठीक है? Metamorphic system. I am not talking about igneous system. What do you mean by invariant point? That means degree of freedom will be 0, right? So this is the invariant point. Am I right or wrong? Clear? Okay. Clear. So you know P plus F will be C plus 2. You know, right? Yes or no? बताओ. If at invariant point the degree of freedom will be 0, this part is 0, so number of phase will be component plus 2. Am I right or wrong? Just tell me. So how many components are there in the Al2SiO5 system or aluminum silicate system? 1, right? So component will be 1, that is Al2SiO5. है कि नहीं बताओ? If the component is 1, how many phases are there? How many phases are there? 3. So that is 3 phases are stable at invariant point. Yes or no? बताओ. Please, like when I teach, no, have some notes. Please make notes according to you, so that when you go to the your like home, back to home, you just revise those points. ठीक है? So at this invariant point only 3 phases are stable. Am I right or wrong? So this is the invariant point. Yes or no? This is the invariant point. At this invariant point, andalusite is stable, kyanite is stable, and sillimanite is stable. yes or no, है ना? uh, Trideep, you have some issue, same issue? Okay, I think Priya, you can like leave and again join, rejoin. Ruby, you have some issue like screen issue? Okay, okay. So at this invariant point, only andalusite, kyanite and sillimanite is stable. Are you clear? इतना समझ में आया कैसे हुआ? ओके, सो नाउ टेल मी कि डिग्री ऑफ फ्रीडम जीरो का मतलब क्या है? If the degree of freedom is zero, that means that is called invariant point. Then what is the actual meaning of degree of freedom? वो बता दो. Anyone? Exactly, right? That means simply you cannot change the intensive variable like pressure and temperature. That means at invariant point pressure and temperature is fixed. Yes or no? This point देखो, this point pressure भी fix है, temperature भी fix है. You cannot change. The pressure and temperature will automatically know कि ये पॉइंट पे प्रेशर सपोज 3 गीगापास्कल है एंड दिस टेम्परेचर सपोज 200 डिग्री सेंटीग्रेड है. ये फिक्स है. क्लियर? दैट इज द एग्जैक्ट मीनिंग ऑफ द इनवेरिएंट पॉइंट. क्लियर? सो इसीलिए हम इनवेरिएंट पॉइंट बोलते हैं. इन द GSI मेंस आल्सो दे आस्क्ड की field, that means he is asking about the divariant field, invariant point, okay, univariant line and divariant or bivariant field. Clear? Can I erase this part? Okay, now comes to second case. Another case is there. Same andalusite, this one is sillimanite. Now talking about univariant line. What is the degree of freedom here? Univariant line पे 1, right? If you apply the same phase rule, P plus F will be C plus 2. If the degree of freedom will be 1, then how many phases are there? C plus 1. Am I right or wrong? Phase will be C plus 1. So कितना component है? 1 component. 1. So only 2 phases are stable. Only 2 phases are stable at univariant line. Yes or no? बताओ. That means this part. See, this part is the univariant line, this part is the univariant line, this part is the univariant line. Where in this particular line only kyanite and sillimanite is stable. So that means along this line the kyanite and sillimanite reaction will take place. Am I right or wrong? बताओ. Any doubt or anything to be asked? You can ask. Please, the basic is very much important for the understanding of the metamorphic reaction. This is very basic. इतना समझ आया और नहीं? बताओ. Any doubt you can ask so that we can proceed like advanced content. ठीक है? Those devolatilization reaction, ठीक है, decarbonation reaction will like go in a while. Any doubt? So along this line, suppose this is the line A along this line the degree of freedom will be 1, where the kyanite and sillimanite will stable, and along this line the kyanite to sillimanite reaction will take place. ठीक है, and this reaction is called the univariant reaction. Clear? इसको बोलते हैं univariant reaction. इतना आपको समझ में आया या एनी डाउट? एट एनी पॉइंट ऑफ डाउट यू कैन आस्क मी. ठीक है, ओके, सेम कॉन्सेप्ट. ठीक है, Andalusite, sillimanite. Now talking about this line, B line. B line पे बताओ how many phases are there, and just properly mention about phases. कि what are the phases at B line, at line B. बताओ कितना phases स्टेबल होंगे? Two, right? Andalusite and sillimanite. As it is line, the degree of freedom will be 1. It is univariant line. ठीक है, clear? At this point line B, Andalusite to sillimanite reaction taking place. Clear? Okay, same along this line also, right? Same. The degree of freedom will be 1, phase will be 2, that means Andalusite and kyanite. Clear? इतना समझ में आ गया सबको या any doubt? Okay, that's great. Now come to third part. Okay, now come to third part. And ये जो लाइन देख रहे हो ना, ओके लेट मी, ये जो लाइन देख रहे हो, इस लाइन को क्या बोलते हैं पता है आपको? काइनाइट, एंडालुसाइट एंड सिलिमाइट. ये लाइन को क्या बोलते हैं? क्या बोलते हैं बताओ? दिस इज कॉल्ड आइसोग्राड, राइट? Where there will be the different type of mineral assemblage, and the stable of the different type of mineral assemblage is there, and where the metamorphic reaction is taking place, that is called the isocrate. Clear? जैसे मान लो यहाँ पे क्लोराइड जोन है, यहाँ पे बायोटाइट जोन है, so this is called the isograde line where the chloride to biotite reaction will taking place. ठीक है, and along this line the chloride and biotite mineral assemblage will be the present along this line. Clear? So इसको बोलते हैं isograde. Now come to third case. Case number third, that is called the divariant situation. Divariant field or bivariant field. What is the degree of freedom? 2. If the degree of freedom will be 2, then what is the number of phases? P equal to C, right? Means at divariant field, the number of phases equal to number of component. Clear or any doubt? So this is the field of divariant, right? This field and this field, इसको बोलते हैं divariant field or bivariant field. So along this field, in this particular field, only kyanite is stable. Yes or no? Along this field, only sillimanite is stable. That means only sillimanite phase. So number of phase is 1, that is sillimanite. So along this field, only andalusite is there. Clear? Ruby, Tridev, any doubt you can ask? Up to this, clear now? Okay, we'll move. Okay. So what is the implication of the metamorphic reaction? I already say कि chemical reaction take place during metamorphism to produce the mineral assemblage and know the stability of the different type of mineral assemblage and to know the pity condition. ठीक है, pity condition of the mineral. जैसे काइनेट मान लो, whether it is stable in the high pressure condition or a high temperature condition. ठीक है, to understand the different type of mineral assemblage and the stable under the pity condition, that is called the implication or application of the metamorphic reaction. That's why we normally study the metamorphic reaction. Okay, so during metamorphism produce the different type of mineral assemblage stable under new condition of the temperature and pressure. ठीक है, in order to understand the mineral assemblage, why they mean in terms of the pressure and temperature of metamorphic. ठीक है, we only study about the different type of mineral assemblage and to interpret the pity condition of the different type of assemblage. ठीक है, so this is all about the metamorphic reaction. Clear? इतना समझ में आ गया या नहीं? And it is only like study under the principle of equilibrium. ठीक है, so इसको स्टडी करते हैं इक्विलिब्रियम स्टडी पे. ठीक है, क्लियर और नो? We can write a reaction expressing the equilibrium between the minerals. Like I already say कि ये जो लाइन है, so this is the line of the equilibrium. इसको बोलते हैं line of equilibrium also or isocrate. So along this line the kinetic and sillimanite reaction will take place. ठीक है, so we can write a reaction expressing the equilibrium between the mineral we see in the rock. ठीक है, suppose मान लो कहीं पे गए हो फील्ड पे, when you go to the any metamorphic terrain, you find the different type of metamorphic phases. ठीक है, so along the phases, no, you study the metamorphic assemblages. ठीक है, and interpret the pity condition of those type of assemblage. So that is the application of the metamorphic reaction in the metamorphic terrain. ठीक है, so we expect that the reaction must have been taking place during metamorphism. When the any suppose मान लो कि sedimentary rock है, sedimentary rock when it got metamorphosed, then only it will start to react. The reaction will start gradually. Okay, so reaction are always responsible. So I just add this content for the, like suppose there will be the question in the GSI mains पे. ठीक है, right, suppose short note आ गया metamorphic reaction, क्या लिखोगे? That's why I am adding this. ठीक है, you can draw the diagram like kyanite, andesite, sillimanite, this type. You can like you can write also the phase rule. ठीक है, this diagram must, if any you are writing any type of subjective question in the metamorphic, you should draw the diagram of the phase L to SI5 system का diagram, or you can draw the metamorphic zone also. So these are the very basic diagram you should draw in the examination. Clear? So reaction always responsible for introducing or consuming. Suppose मान लो कहीं पे reaction हो रहा है, A plus B will be C plus D. Okay, suppose this is the reaction, this is the basic reaction. Whether any type of mineral, suppose यहाँ पे B consume हो रहा है, suppose, and produce C. ठीक है, so from this reaction you understand the concept of consumption. ठीक है, and what are the different type of mineral it releases during the metamorphism whole process. Clear or नहीं? जब रिएक्शन होता है, रिएक्शन will only responsible कि suppose any other mineral or any rock got metamorphosed. So during the metamorphism process, what are the different type of mineral consumed, or what are the different type of mineral it will release, or any phase will release. So that is the main application of the reaction. Clear? Classic isograd still useful in the field need only be the able to recognize the new mineral in that specimen. अभी बताया था, suppose मान लो metamorphic terrain पे गए हो, कोई phases मिल रहा है, suppose you find the eclogate phases, you should understand the different type of assemblage in the eclogate phases. ठीक है, so you should recognize the new mineral or new mineral assemblage in the hand specimen also. ठीक है, so if you understand the reaction that produce mineral, the physical condition under which reaction occur and variable affecting them, we can better understand metamorphic process. बता दिया था, ठीक है. You can also like identify in the experimental way, ठीक है, and identify the different PT condition of the mineral assemblage. So let's talk about some of the reaction, ठीक है, because I think the whole metamorphic reaction will not complete, but let's talk about this. I already this mention univariate reaction. Suppose कहीं line पे where the degree of freedom will be कितना होगा बताओ, 1, right? So metamorphic reaction taking place. Okay, univariate reaction, divariate reaction, polymorphic reaction. कोई polymorphic reaction का example बता सकता है? Anyone? Exactly, right? Aragonite calcite. Any other? Any other? Ruby, any other? Exactly, exactly. L2SiO5. It is also polymorph, right? Any other? Quartz also, right? Quartz polymorph. It is also a reaction of the metamorphic reaction. Suppose मान लो PT. कहाँ पे aragonite प्लॉट करूंगा, कहाँ पे कैल्साइट प्लॉट करूंगा बताओ. Suppose aragonite is high pulsar, right? It is not like stable at the surfacial condition, right? And this field is the calcite, right? It is the high temperature polymorph of CaCO3, right? And aragonite also high pressure polymorph of CaCO3. Read about this mineral also. This is very important. जो normally common use होता है ना हर जगह, जैसे quartz is a very important mineral. You can get such different type of question, जैसे quartz का optical properties हो गया, ठीक है, quartz का hardness हो गया, quartz का composition हो गया, quartz का physical properties हो गया, quartz का polymorph हो गया, ठीक है. Read about those type of mineral also is the mineralogy. That is very useful. Whatever you study in the day-to-day life or naturally, that is the important mineral. जैसे aragonite calcite आ गया ना, normally ये use होता है हर जगह. So that is most like important part. Garnet हो गया. Garnet is useful in the very geothermometry, geobarometry, right? So that is the most important mineral normally. So then we'll discuss about solid reaction, devolatility reaction, ठीक है. So अभी बता दिया था univariate reaction. Please go through this. So like any andalusite sillimanite or releasum fluid also, right? Along this line, not only like kyanite selenite, along this line whatever the reaction will take place is called the univariate reaction. So univariate reaction for a given rock composition, a univariate reaction is one that plots as a line or curve. जैसे मान लो ये कर्व है, अभी एग्जांपल दिया था ना, दिस इज द gentle slope and this is the बताओ steep slope, right? क्यों gentle slopes, क्यों steep slope हुआ है, कोई बता सकता है? From this reaction, this is very important, ठीक है. This is called concave upward curve. Okay, this is the gentle slope, okay, and this is the steep slope. Why it is slope, क्यों हुआ है यहाँ पे gentle slope और like concave upward pattern? Why it is steep slope? This part. See, the steep slope will be the at high pressure. At high pressure, the slope will be steep. Am I right or wrong? At low pressure condition, the slope will be gentle, isn't it? Are you getting my point or no? Ruby, are you clear? Exactly. Or you can not only see the if you see the pattern, the main question is from the example. Suppose example they there. This you should remember, right? This you should memorize, but you have to understand what is the univariate reaction taking place, and this also you can see, or you can also say about this is fluid releasing reaction, ठीक है ना, that is dewatering reaction or a dehydration reaction. You can also call it this is the dehydration reaction because it releases some of the fluid, right? H2O, it releases the H2O. If it releases the CO2, what is the reaction called? Let's talk about this. Okay, Priya's as the exam oriented question, but read those type of proper reaction. Suppose मान लो A plus B equal to C plus D plus H2O. What will be the reaction? What is the name of reaction? बताओ. Priya, you said. Robi. Just tell me the reaction name. Are you there or left? Okay, just tell me. Not hydrolysis. Hydrolysis is different reaction you study in the weathering process. It releases the ion, right? Simple. It releases the ion. Hydrolysis is different. There will be the sum of the difference between the hydrolysis and hydration. Am I right or wrong? Hydration is simply addition of the H2O. Hydrolysis, when it dissociate, it will produce to ion like H plus ion or OH minus ion. So that is called the hydrolysis process. But I am talking about this type of metamorphic reaction. I am not talking about those weathering reaction or like chemical weathering. Exactly, right? Dehydration. See, H2O act as the volatile here, not like HC. The water will also, water will also occur in the structure of the any mineral. That is different. Structure of any mineral. You see, suppose mica or moscovite बोल दिया, moscovite. Take it moscovite. The OH will present, right? The water will present in the structure. It doesn't release the water as the volatile. So this reaction is releases the volatile here. Okay, H2 is the volatile, right? It releases the volatile. That's why it is called the dehydration reaction. Dehydrated. That means the water will release out or volatile will release out. That is called the dehydration reaction. Clear or any take on this? Clear? Tridip, yeah, you can. बताओ. Also, sometimes, see, the discontinuous and continuous is the different concept. Tridip, as you mentioned the discontinuous reaction, then what is, you tell me what is the exact meaning of the discontinuous reaction and continuous reaction? Discontinuous reaction and continuous reaction. हम जाएंगे, इसको भी जाएंगे. That's why I always put importance on the metamorphic reaction because it is asking in the many examination. That's why it will take time, 1 or 2 classes maximum or 3 classes. Because I will go from the very basic, right? Discontinuous reaction. Just tell me. That means in the type of, हाँ बताओ, त्रिदीप बताओ तुम, तुम्हारे एंड कंटिन्यूअस रिएक्शन पे एनी अदर टेक? वन बाय वन. हाँ दिनेश, हाँ दिनेश बताओ. ओके ओके. Any other take on this? Exactly. That is the most important thing. It is fixed at a particular temperature. Am I right or wrong? At this particular temperature, the new mineral will form. At a particular temperature, it is not continuous. It is discontinuous. Okay, that means the reaction is going on. Okay, at this particular point, the new mineral phase will come. That is called the discontinuous reaction. And the continuous reaction is, it is continuously happening. The reaction is continuously happening through the PT condition. Just I have add something. Let me. Yeah, this. See, if you correlate with the igneous phase diagram, right? Along this particular point or along this particular temperature, that means 1274, the new mineral phase will come, right? Am I right or wrong? That means diopside will form. If you take the melt composition here, it is continuously reaction is happening along this line. But when you reach the eutectic point, at a particular temperature condition, at a particular temperature, the new mineral phase will come. That is called the discontinuous reaction. So along this eutectic point, discontinuous reaction will happen. But along this line, when melt will come, when we melt the cool, okay, along this line they continuously reacting with a different composition of the liquid. Clear? हम जाएंगे, gradually जाएंगे. That's why I am saying कि keep patience. एक दिन में अगर हाँ this question से अभी बताया. Tell me what will be the answer? बताओ. P, right? P plus F will be C plus 2. That means F will be C plus 2. हाँ बता रहा हूँ. So this is called the F will be C plus 2 minus P. That means this part. I already stated condensed phase rule or reduced phase rule. P plus F will be C plus 1, right? Where either the pressure is constant or temperature is constant. Normally pressure constant होता है. Pressure is constant in the phase diagram. ठीक है? At a particular pressure, suppose मान लो 3 gigapascal. What will be the degree of freedom or what will be the Gibbs phase rule? Okay, इसको बोलते हैं under isobaric condition. Clear? This part. बताओ. अभी तो बताया हूँ मैं ये क्वेश्चन. हाँ? Very good, right? This is called isograde, right? अभी तो बताया हूँ. What about isopack? This is called vertical thickness, right? Between two bed. Isocontour, line of phase change. बताओ. The line of phase change मतलब simple. Along this line, what are the different type of mineral will come. But see, a specific change in mineral assemblage. That means mineral assemblage will change, also reflecting a mineral reaction. ठीक है? Under the reaction of equilibrium is called the isograde. अभी तो बताया था मैं. Clear? The answer will be isograde. Clear? Or any doubt? See, all these type of line is called the isograde line. So along this line, what are the different type of mineral assemblage or what are the different phase will come and come out. ठीक है? And what are the different type of reaction is happening also. not only mineral assemblage, ठीक है, isograd मतलब what are the different type of mineral assemblage and what are the different type of mineral reaction is taking place. That is most important. Clear or any doubt? बताओ. We'll stop because it's already 50 minutes. We'll stop. I'll take class tomorrow. Okay? Because no, I don't want to take the live class because like few students are come. I don't have any motivation for the live classes. That's why I'm uploading directly in the YouTube. Which classes do you really enjoy? I think the live class will be better, right? Live class is better, but I know also, right? Live class is better, but thing is, no student is coming, right? Since like I have sent almost like 50 or 60 student, I think 50 student register for this course, but see, okay, but it's okay. Gradually the definitely will come. It's no problem. Tomorrow we'll have same time. I will send the link for the tomorrow class. Okay, 8:20. We'll start from the this reaction, univariant reaction से बातचीत करेंगे, ठीक है? Okay. Hope so you like it. ठीक है, ये अपलोड हो जाएगा YouTube पे. Any doubt till now? See the devolatile reaction. Devolatile, that means the volatile will release. Volatile will release. ठीक है, at high temperature. High temperature. That means the prograde. सेम कॉन्सेप्ट, यहां से कॉन्सेप्ट आएगा ना पीटीटी पाथ, यहां से कॉन्सेप्ट आएगा पीटीटी कॉन्सेप्ट. ओके, वोलेटाइल विल रिलीज एट हाई टेम्परेचर, दैट मींस द प्रोग्रेड मेटामॉर्फिज्म will happen, this type of. Okay, time, and this is called retrograde. That means temperature is gradually decreasing, so Tmax will come first, Pmax will come later. This type of concept will call. जब भी पढ़ रहे हो ना, वन टॉपिक सपोज मान लो पढ़ रहे हो, यू कैन कोरिलेट. सपोज मान लो मेटामॉर्फिक रिएक्शन पढ़ रहे हो, राइट? यू कैन ऑल्सो राइट इन द जीएसआई मेंस इन ए ब्रॉड वे, ठीक है? लाइक मेटामॉर्फिक रिएक्शन से क्वेश्चन आएगा, यू कैन राइट द मेटामॉर्फिक फेसेस ऑल्सो, ठीक है? You can draw the diagram of the metamorphic phases and the different type of mineral assemblage at a particular phases. Suppose इक्वलोगेट phases पे कौन सा mineral stable है, ठीक है? How the different type of mineral will react each other and give to the another mineral. That is most important. ठीक है? ये सब कल पढ़ेंगे devolatile reaction. It will take time, 1-2 classes. Okay? Any doubt? Or we will conclude the class. Okay, we'll see tomorrow. Okay, I'll send the link. Okay, good night.